In the previous tutorial, we learned how to apply the information hiding principle to improve a simplified version of the online buying system. If you recall the example, let me just bring you to the slides discussing the lecture for the motivation for the iterator pattern. So this is what we developed in the previous tutorial, where we said if the clients, so now we have the clients and the supplier. The client is actually the shop class, and the supplier is a cart of a collection of orders. So in this case, in the bad design, the supplier does not hide the secrets about how the orders are represented using either an array or linked list or other data structure. So the clients, in client's code, for example, the checkout feature, where the client is trying to figure out the total price for the current orders in the current cart. So because the orders from the supplier side was not hidden, so the client could actually get access to it directly, which means the client's code can be very specific to the current representation of supplier's secrets. Something that's supposed to be secret, but it's not secret yet. So you can see that here, for example, in the loop of the client's code, the client actually accesses a feature called lower and also another feature called upper. And these two features are very specific to the current representation of the supplier's implementation, which is an array. So the problem for this is later on, if supplier decides to change the design decision, which means there's something that has to be hidden as a secret from the clients, let's say from array into a linked list, or from a linked list to some hash table, or from some hash table to some tree structure, then this means client's code would no longer compile because changing from one data structure to another, meaning that would mean that the client has to use a different interface for that particular data structure. So this is really the problem if the information hiding principle was not applied. Recall again, it's very important, one of the very important course learning outcomes that you should know the principle of information hiding. So information hiding is really the process for the supplier to decide which design decisions should be declared as a secrets that will be hidden from the clients because these design decisions will be subject to changes later on after after the interface of the supplier class has been published. So the supplier wants to make sure that the public interface that it published to clients and the client may rely on the interface, and the interface itself should contain nothing that's unstable. Unstable meaning that it is subject to changes. So in this case, because orders might be subject to changes for its representation, so this should have been declared as a secret by using the feature exported to none syntax in iPhone. Okay, so this is a recap from the previous tutorial. If you still have doubts about how to adapt a bad design into a good design using information hiding, please refer to the previous video. In this tutorial, we're actually going to show you one way to implement the information hiding. In the previous tutorial, we show you one possibility of applying the information hiding, which is first to declare this feature of orders to export to none, and then we actually move the checkout feature into the suppliers class because it is okay for the supplier to know its secrets. So if the supplier changes its representation for the orders, it will also change its checkout feature in the same class, which is okay. And now in the client class, in the previous tutorial, we said it would be just a one line implementation for the checkout feature because the client can simply just call the checkout feature in the supplier side. And whenever the secret is changed from one representation to another, as soon as the supplier uh, changes the implementation for the checkout feature on the supplier side accordingly, the clients would not be affected. So that's the solution we presented in the last tutorial. Please refer to it if you still have doubts. in this tutorial, we're going to show you a different solution. The first step still is to make sure the orders is exported to none. Okay, that's a common step with the solution we presented in the previous tutorial. But we're going to show you a design pattern that is called the iterator pattern. And this pattern here will actually show you how it is possible to actually have a uniform way for the clients to access the collection from the supplier side. And it doesn't really matter what the underlying data structure is. It is that the supplier has chosen. And for the clients, it is always possible to access the collection by using some uniform interface. So this solution in some way is more general and hence better. And thus better solution than the previous one we presented in the last tutorial, because in the previous solution, that means every feature that the client needs, we need to also support it in the supplier. So in some way, this is not so flexible for the clients, because if the clients want to define some feature that may not be already supported in supplier's interface, then that means the client has no way to just walk through the collection themselves. So it too much relies on the supplier's supported feature, like a checkout or other features. Okay, so please make sure you also understand by the end of the tutorial, also compare the two possible solutions that actually both apply information hiding, but one is actually more general and more flexible than the other. Okay, in this current solution we're going to present, it's going to allow the clients to have more flexibility by being able to walk through the collection of items from the supplier side using some uniform interface. Okay, that's really the essence for iterator pattern. Okay, so let us just review the architecture diagram for the iterator pattern. Let me just show you a better one. Okay, so we are now not worried about the client side, because the client side we already covered that in the lab session about how you can use the in the client side you can declare some attributes of type iterable, and after that you can actually use a cross syntax for both precondition and postcondition invariants, which means for the contracts, and you can also use the cross syntax for writing loops for your implementation body. Okay, we already showed that in the lab session. You can refer to the video of that if you have any doubts. So in this tutorial here, we're going to consider the case, the side of supplier. So now let's say we have a card class. So the card class, we want to make it a descending class of iterable, so that it can actually, so that when the clients declare some attributes of type iterable, and in this case we can put card here because card will be a descending class of the iterable. In that case, the clients will be able to just have one single way using the interface of the iterable to actually access the underlying data structure in the card class, meaning the orders. Okay, so in this case, in this tutorial, we're going to show you a simple case, because remember the data structure that the supplier is using for the orders. Let me show you here again. Remember this design here. So now let's say the orders is actually of type array. So array is actually a library class in IFO. And as I show in this architecture diagram here, so array is an effective class, which means it implements all the deferred features already. So nothing is deferred in array. And array, if you look up in IFO Studio, array is actually a descending class or a child class of iterable. So that means array already supports the implementation of the necessary feature to be iterable, which is the new cursor feature. And you can see that the new cursor feature is of type iteration cursor. So this is really the uniform interface I was talking about. So by returning this new cursor from any iterable objects, then the clients will be able to use the three supported features after item and forth. So these should be the familiar cursor operations that you have been using so far for the linked list. So in this case, the iteration cursor supports the 3 features that would be sufficient for the clients to actually iterate through the supplier's secret collection without worrying about whether the collection was implemented by using array, linked list, or array list. Okay, so that's really the basic idea. So now in this tutorial, we're considering the simple case because we do not have to worry about implementing anything to anything that's under iteration cursor, because this iteration cursor is already implemented because our array, linked list, and array list they are already supported in ifo library. Okay, but in the next tutorial, in a later tutorial, we're going to consider the case where you do have to inherit your own. You do have to define your own class that inherits from the iteration cursor. Okay, so that would be the case for the book projects that we did also in the previous tutorial, but let's not worry about that for this tutorial. We want to do one thing that's very simple just to get you started and get you to understand the idea better. Okay, that's basically the architecture for the iterator pattern, and we are only going to reuse the new cursor feature that's already supported in the array class in the ifo library. Okay, so we don't actually have to worry about how to implement the after item and also fourth features for the array. Okay, for this tutorial, just want to make it simple. Okay, that's basically the overview for this tutorial. Let's, as usual, let's go to our 3311 workspace and then make sure you launch the ifo Studio. And for the current semester, summer 2015, we're going to use the version 15.01 ifo Studio. Okay, launch that, and let's go to your. So here, I haven't seen anything here in the open project yet, so let me just add it. Okay, we're not really creating a brand new project, but we are trying to build on top of the projects of the shop, the shop projects that we built from the previous tutorial. Okay, so let's click on that and choose the ECF file, the configuration file, and then we say OK. So now the project has been added, so now we can just say open, and now it will just compile from scratch. Okay, so now what we should do is very briefly to look at from the previous tutorial. We actually we have a root class, and we have the tests directory cluster. We haven't put any test cases yet. That will be your job to write test cases for your application. Under the shop, we actually have the order class. Okay, so for each order, you have the product name, you have the price, the unit price of the product, and and the quantity demanded for the particular products in this order. Okay, we actually show you the batch version of the sign using the batch card and batch shop. And batch card and batch shop corresponds to exactly the diagram, the supplier and supplier ifo code fragment I just showed you here. So this is really the batch. This is really the batch shop, and this is really the batch card. That's the batch design. And in the previous tutorial, we also developed the good card and good shop. In the good card, we apply the information hiding by export the orders of array to none, so that the good shop, which is the client, cannot get access directly to the orders, right? Okay, so and also we define a feature called checkout in the good card, which is a supplier, so that only this feature also in the supplier side has access to the secrets about how the orders is represented. So later on, if the orders actually changes from, let's say, from array into linked list, only the supplier side has to be changed. On the other hand, if you look at the good shop class, which is the clients, they will only have to have a one-line representation. And whenever the supplier changes their secrets, once they redefine the checkout from their side, the client can just reuse it without having to worry about that the code wouldn't compile anymore. Okay, that's basically what we did from the last tutorial. Please refer to it if you have any confusion. In this tutorial, we are going to create another version of the good design using the iterator pattern. Okay, so to save your typing, we're going to do some copy and paste. Okay, I'll show you exactly how to do. Okay, so now let me just declare some local variable here so that we can get all the blue. We can also get the good card and good shop into blue so that we can compile that, because we need some references to them so that the iPhone compiler would know to compile anything that's being used. Okay, so good shop. So if I compile this, we're going to see, so these two turn to blue. Okay, which means they are now in the universe for being type checked. Okay, so now we're going to create two classes. One is good card 2, which means version 2 of the good design, using the iterator pattern, and also good shop 2, which will be the clients of the good design that uses the iterable card. Okay, so now let's create two classes in the same cluster. Okay, under the shop, so let's say add a new class, and we'll say good card 2. Okay, okay, so I can say here second version of good design with information hiding using an iterator pattern. Of course, if you find this a little bit too long, what you can do is to make it into several lines. And the way to do this is to use the block comments, which will start with quotes, left brackets, and close it with right brackets and quotes. Okay, so now I can break the comments into 2 lines, so it'll be more readable. Okay, so you should also know this by now. Okay, it still compiles. So now for the good card 2, to begin with, we're going to just copy and paste the code from the good card, and then we'll do the necessary changes later. So open up a new tab here, and then go to good card. Okay, we're going to copy everything from, except the name, of course. So we go from the creates, okay, go all the way up to the end, and Control C for copy, and then we're going to paste that into here, and of course we're going to make sure it compiles, and it does. Okay, let's do another one, exactly the same procedure for good shop 2. Okay, let me close these two. Okay, so now click on shop cluster and then say good shop 2. Okay, so here we can simply say clients of good card 2 using the iterator pattern. Okay, and we'll open up a new tab. I'll double click on here, and then let's go to good shop, and then we'll copy and paste the code except for the class name up to the end. And now we're actually going to paste that for good shop 2. Compile. Okay, everything compiled now. So I'm going to leave good shop 2 here, open up a new tab, and go to good card number 2. Okay, so these are the two classes we'll work with for this tutorial. Okay, so now good shop 2, basically we still have the we still declare the card of the good card. Okay, however, we got to change this to good card 2, right? So don't forget about this. It is a very crucial step because now we're talking about the second version of the good design. So it has to refer to the right version. Okay, so don't get confused. Okay, so now you can see that this is still the solution from the first version. So in this case, what we want to do is to make the good card 2 iterable so that the implementation for the checkout will be a more flexible implementation. Well, it wouldn't be a one-line implementation, but the point is, later on, if the client want to support any other commands or queries, not necessarily checkout, they can the client can simply just use the iterator constructs to access to the collection without having to worry that if the supplier on the supplier side, if they support a corresponding feature, for example, like checkout. So that's really the advantage for this second version of the good design with information hiding using the iterator pattern. Okay, so let's just actually, okay, so basically the functionality would be the same. Okay, however, what we want to do is to say somehow to say we haven't done this, but let's write the comments first. Since good card 2 is iterable, the current client is able to iterate through it using the across syntax to using the return cursor or the across syntax. So in the exercise 1 of this week's lab, you actually learn to see how you can write an implementation body using either the cross loop or a normal from until loop using the cursor. I might show you briefly in this tutorial how you can do both versions. Okay, right. So I'm going to just delete this implementation for now and we'll fill it in later. So let's first make sure that good card 2 is now iterable so that we can use it. Okay, other parts actually remain the same. Okay, as far as the client is concerned. Okay, now let's go to good card 2. Okay, so now the advantage for the second version of design is we now don't need a corresponding feature in the supplier side. We don't need to because we're going to make the collection iterable while still hiding its detailed representation. Okay, I can delete this. Okay, that's an important thing to know. We don't need any corresponding feature on the supplier side anymore. Okay, so let me go to good card 2. What I need to do, this is something new for the second version. So I'll say inherits iterable. Okay, if I simply say this, it is not going to compile. You can see what the error message is. Type has wrong number of actual generic parameters. Okay, also by now you should be able to know what this really means. Okay, if we expand the error messages, it's saying in the base class we have an iterable of G, where G is a generic parameter, but now we haven't instantiated that generic parameter yet. Okay, in this case, we want to, from the supplier's point of view, which is the good card 2, we want to make the orders iterable by any potential clients. Okay, so what should be the item that the clients can actually iterate through in each iteration? Okay, that should be order, right? Okay, you can see that in this case, the array is really the detail or internal workings of how the orders are organized together. However, as far as the client is concerned, they don't actually care about if this is an array or a linked list. What they really care is, I just want to see all the orders in a linear fashion. Okay, that is why we actually have to say inherits order. Okay, please make sure you know why we need iterable order rather than just iterable, and also why we choose order to be the to instantiate the G for iterable. It is very important for you to know. Okay, if we say compile, okay, and then now we got some error message here. It says class has deferred features, but it's not declared as deferred. Check the deferred feature new cursor from iterable. Okay, so basically this is what this is saying is this class here inherits from some other deferred class. Okay, if I just open up a new tab and then let's go to iterable, you can see iterable is actually itself deferred because it's the only feature here. You can see from the groups panel here under access, there's only one feature called new cursor, and this feature here is deferred. That's why this class is deferred, because there's no implementation supplied in the new cursor feature. So this is to say, if we have a class that inherits from something, some class that's deferred, if we choose not to implement this feature still, then this class should be a deferred class. Okay? On the other hand, if we inherit from some deferred class, However, we want this class to be non-deferred or effective or concrete. Then we have to implement that deferred feature. So this is what the error message is saying. So please make sure you understand what the error message is trying to tell you. So what we need to do basically is to define a new feature section. Let me just put it after queries. Okay, so what we need is something for iteration or iterable. Okay, so now we need the new cursor feature that's inherited from the iterable. Okay, so new cursor, which has to return, let me go back to iterable, you can see it should return this type, which is iteration cursor of G. You can see this G here is actually should be consistent with the G that's instantiated to the iterable class. Okay, by now you're also supposed to know how this works for the generic parameter. Let me say that again. This iterable class is parameterized by the type G. Okay, and all the G for the rest of the code should be consistent with whatever this G is instantiated. So for example, if this G here is instantiated as order, then this G here will also be instantiated with order accordingly. Okay, so this is why. So here when we say new cursor, okay, because we have just instantiated the G for iterable as order. So now here we should say iteration cursor of order. Okay. Okay. Iteration cursor of order. Okay. So now we're going to first compile. Okay. So now this message here, you should also know variable is not properly set result. So this has something to do with void safety because iteration cursor is actually a reference type. So by default, its default value will be void. So however, we have, and this would be disallowed in the void safety, where the void safety flag is turned to complete. The option is turned to complete. So what we need to do is to somehow get some iteration cursor. As I said before in the architecture diagram, because currently the implementation is actually orders of type array, and as we see from the architecture diagram here, in the iterator pattern, the array is actually a library class that's already iterable, and array itself is actually effective, which means it must have implemented the new cursor feature that is of type indexable iteration cursor, which is a subtype of the iteration cursor. So it would be acceptable to just return from the array. You can just you don't have to reinvent the wheel. Okay, you can just reuse whatever that's already implemented in the ifo library. Let me go back. So here, the implementation for this new cursor feature here would just be as easy as just one line implementation. So result is assigned to implementation, which is of type array dot orders dot new cursor. Okay, this new cursor is guaranteed to be implemented already because array is actually not a deferred class. So everything that you can call from there has its own implementation. Let's double check. Okay, go to this tab. Let's go to array, and if you go to let's say new cursor, you can see that in a superclass or in a parent class of the array, which is called readable indexable, they already have the implementation already. So we're just going to reuse that without having to define ourselves. However, this is the simple case. In other cases, let's say if you are using some implementations representation that may not have the associated new cursor feature defined, then you will actually have to define some new descendant class of the iteration cursor, and you have to redefine the new cursor feature for that, right? Okay, that's basically, and also you have to define the after item and fourth features for that particular descendant class. Okay, but that's not the case for this tutorial. But we'll show you in a later tutorial. In that case, which is more challenging, but how can you do it? Okay, that we'll do that later. Okay, so now let's try to compile. Everything compile. Let's just fix these comments very quickly. adoption of the information hiding principle, and if the supplier changes the design, okay, from array to linked list, then all parts of the clients, okay, this is not true anymore. Then I can say the only part of the cards client's code. Actually, sorry, it's actually talking about the client. So this is okay. Okay, let me just undo it. All parts of cards client's code will not be affected. Okay, that's good. Changing this will only affect the supplier side. Okay, okay, that's good. Okay, we'll only change the supplier side. Yes, because i.e. good card 2 new cursor feature, which means if now the supplier changes the orders from array into a linked list, then what the supplier might have to change would be how to define the new cursor feature. Okay. However, let's say in the case of changing from array into a linked list, there wouldn't be any change in the supplier. Okay, that's very convenient. Okay, but that's not a general case. I'm just saying this is a special case where there's no change because you can see that array is a subclass of iterable. Linked list is also a subclass of iterable. So linked list also has a feature called new cursor implemented already. So if you change from orders from array into linked list, it would still just compile. Of course, there might be somewhere you have to. Okay. So we just got other features where it actually uses the array notation, like a lower and upper on the supplier side. Okay. So basically, so after, so whenever you change from the orders representation, but the only place you have to change would be on the supplier side. For example, you can see the compile errors all come from good card 2. There's no good shop 2 here, right? So only the supplier has to adapt to the changes, but not the clients. So that's a crucial point about information hiding. Okay, but as you can see here, all the compiles error here, it has nothing complaining about the about the lower, about the upper, and also about the force. Okay, they are all specific to array and also the make empty. However, it complains nothing about this new cursor feature because in the case of linked list, the new cursor is also supported. So this part of the code of supplier does not have to be changed. Only the code that's specific to the array implementation has to be adapted to the linked list. Okay, please make sure you really get my point, otherwise you have to repeat watching. Okay, let me just change this back to array. And let's compile, everything compiled. So now we completed the side of the supplier by making that iterable. Okay, make sure you also know why we actually have to instantiate this to order. One more important note to you. This is iterable. Iterable of order. If you contrast this iterable of order with array of order, you can see both of them are collection. So let me just write this out temporarily. So array of order, and also you have iterable of order. Okay, if you compare these two collections, this collection here has a very specific notion of how the data are stored, like they store in a linear fashion, like array, right? So they're indexed by the indices with lower and upper. Also, you can force into it, you can actually put into it, right? However, for the iterable, it's actually a much more uniform and more general interface for accessing something which you don't really care about how it is internally represented either as an array or as a linked list. Because for the iterable, it only supports a new feature like to return back to the client a cursor for accessing whatever that's internally that's used to internally represent the collection. Okay, please make sure you also get this point. So now, as far as the client is concerned, they don't need to know about this, but they have to know about this iterable order. Okay, that's all they have to know. Okay, let me delete this, and it still compiles. Now, in the good shop 2, which is the clients, let me also close this. Okay, so now you can see that the declaration on the client side, good card 2, does not have to be changed. You don't. Oh, okay. So what you could, well, because good card 2 is already iterable, so as long as you declare something that's iterable, you can already use it. Okay, this is one way, or you can say, for example, iterable of order. If you put it here, then you have to do a little change to the constructor. Let me show you that so you can actually know both ways. Okay, so there are two ways to declare the attributes. One way is to say, if you simply say card, okay, you will compile, sorry, card 2. So good card 2, good card 2, okay? So this will compile. So one way is to say, I have good card 2, which is itself iterable, and then the way I initialize that is by create the card by calling the make feature, which is the constructor for the card, okay? Another way to do it is to say, now I want to simply iterate through some iterable of order, okay? In this case, because iterable is actually a deferred class, so you cannot directly uh, actually call its constructor. So it is actually more recommended to simply say the direct supplier's name. It would be more recommended. Okay, good card 2. Okay, so now because good card 2 is iterable, okay, is iterable. So now we can actually return some cursor from the card, right? Okay. So now let's see how we can do the checkout here by using the card. Okay. So now because good card 2 is actually iterable, so what we can do is to, for example, declare some local variable here, and then we have some cursor of type iteration cursor. So acting as a client has been done as an exercise for you in this week's lab session. So please refer to the video for that lab session if you still are not so familiar with how to act as a client of the iterable. Okay, iteration cursor of order, and let me just make sure it compiles. And now we can return the cursor from the card. If you say card dot new cursor, because good card 2 has been just made iterable. Okay, and now we can actually say from, okay, so now we actually want to calculate the total price. So let's say result should be initialized to be 0. So now we're going to go through the list, go through the collection until cursor now is beyond the last position, which is represented by this Boolean flag. You should know that by now. And then in the loop body here, of course, we have to at the end of each iteration, we have to say cursor dot fourth. Okay. And now in each iteration, we can say result is equal to, we're accumulating result by result plus cursor dot item dot, because we have instantiated the cursor using the order, iteration cursor using order. So that's why when we say item here, it would be of type order. So that's why IFA compiler will be smart enough to tell you in the order class, you have these features available. So now we want to just calculate the quantity times cursor dot item dot price, unit price. Okay, so that would be the implementation for the client side using the cursor. Alternatively, okay, you can actually use the across syntax for this. I would just say this is version 1. Version 1. Use normal loop on the return cursor. Okay, so now we're going to do some version 2. Version 2, okay, use the across syntax. Okay, you say across, press enter here. So we'll say across the card, right? Because card is iterable. Okay, card as So we can also, so let's not say cursor because we are actually going to use the local variable called cursor. So we need to choose a different name. So we can say, what about just C for the card, for example? So now we can say loop. Remember, do not say C.fourth here because in the case of the across, the C.fourth is implicitly called for you, so you don't have to worry about it. Okay, it's like a syntactic sugar for you, basically. So here you only have to say that result is assigned to exactly the same as before. So please let me just copy this to save time. And we're going to copy this and to uncomment that and fix the indentation here. Okay, so this would also work after I change the name of the cursor. Of course, it will be C rather than cursor. Okay, so this will be a version 2 of the implementation for the checkout feature in the clients. Okay, so both versions will work. So it's really up to you. Okay, so if I should know both versions. So version 1 requires the explicit call of the new cursor from the card. Okay, version 2 actually, because we're using the across feature, so two things are done implicitly for you. First, card.new cursor call is implicit and it is already assigned to the new variable C. So C is a cursor variable, as we said in the lab session. Okay, second thing that's implicitly called is C.fourth. So please make sure you don't actually say C.fourth in the case of across. Okay, that will actually cause some error if you do that. Okay, basically that's really the first version of the iterator pattern I want to show you, which is simpler version. In this case, let me recap again. We actually have the good card 2, which implements the iterator pattern by making itself iterable, and because the client would like to iterate through orders, so that's why we instantiate the formal generic parameter of iterable, which is G by order. Okay, so you can now see, because we export the orders to none, so this array type here is not known to the clients. It's completely hidden. So later on, if we change from array into any other data type, like a linked list, only the code from the supplier side has to be changed to adapt to this new change. Okay, no code has to be affected on the client side. That's really the important guarantee from information hiding. Okay, and as soon as you actually inherit your supplier class from iterable, what you have to do is to implement the inherited feature called new cursor of type iteration cursor. Okay, in this case, because we're going to iterate through order, so this will be order as well. And as I show in the architecture diagram of the iterator, so in this case, because array, linked list, or array list, or others, they are the library classes from IFO. So they have, and they are actually indeed iterable. So they have already implemented the new cursor feature for any potential clients to use. So in this case, we do not have to redefine the new feature, the new cursor feature. We do not have to reinvent the wheel. We can just reuse it. So this is a simpler version. So, however, in a more challenging scenario, we may have to actually redefine. We have to create the new class that inherits from the iteration cursor ourselves. Okay, but that will be presented in a later tutorial video. Okay, so that's basically what I want to say for this tutorial video. So please make sure you try to reproduce this more extension to your shop projects, and please make sure you also review the architecture diagram for the iterator pattern, and you should also try to reproduce the diagram for this particular shop example in Visio, and to actually show that how this architecture diagram can be instantiated into your shop projects. Okay, and because you might be asked similar questions on the test, exam, or the projects. Okay, so please make sure you do the exercise on both iPhone Studio and the Visio drawing tool. Okay, stay watching.